Good morning, everybody. Welcome to snowy, cold Wednesday morning of Chem 1211 with your host, me, Dr. White. As I asked yesterday, I'll ask again. Who's ever dreaming of a white Christmas? It's too early. Stop. All right. I have a lot of other important things to do, and let's get to it. But first, I have to open up something. I'm logging into Blackboard now. All right, everybody should be seeing quiz 5, important information. And early this morning, 6:30 this morning, I sent out the following email, and this announcement was posted. On next Tuesday, the 22nd of November at 11 a.m., right after our class on Tuesday, at that time, I will be emailing you the password for quiz 5 PDF file. You'll have, and I gave you extra time because I'll explain why in a second. You'll have until Wednesday evening, the 23rd, till 8 p.m. to take quiz 5 and to upload your answers to quiz 5 as a single PDF file. I reserve the right to subtract up to 25 points from your quiz 5 point total or total points for anyone who doesn't follow instructions, meaning a single PDF file, or does not upload your quiz 5 answers on time. I don't know why, but Blackboard, when I post it in here, messes up the spacing. But anyways, quiz 5 has 5 pages, 9 problems, including some multiple part questions like A, B, and C, but no multiple choice questions. Ooh, tea in the morning is good for you, for me at least. It's worth quiz number 5 is worth 50 points. It covers chapter 15, chemical equilibrium, including collision theory of reactions, rates of reactions, chemical equilibrium, including, I should have put there, and Le Chatelier's principle. There's my North Side Chicago French accent. Now, I'd recommend that you download the day before I give the quiz, which means next Monday afternoon, I'll post the quiz PDF file on Blackboard. I will post the quiz 5 scores the following Sunday after that Wednesday or earlier. And also I will send out an announcement that I posted them in Blackboard, and by Sunday, 1 p.m. or earlier, don't forget next week, Thursday is Thanksgiving, I will also email individual students the points you receive. The Monday after the quiz, I'll go through the answers for quiz 5 on our video Zoom meeting, but I will cut it out of the video. You can't make it to a Zoom meeting on a week from this Monday, then come to my office hours or contact me to set up a private Zoom meeting. Now, one thing I also posted this morning, under course information, go to lectures, scroll near the bottom, and you now will see quiz 5 review. which I have both as a Word document and a PDF file. Oops, that's not what I want. And here's quiz 5 review. All right, next Monday, I will go through quiz 5 review in our Zoom meeting. I will also go through the chapter 15, which is quiz 5, chapter 15 problem set in our Zoom meeting on Monday, which, if you think about it, my personal goal always is to stop or finish lecturing a week before a test or a quiz. And today, actually, yesterday, I finished up everything for chapter 15, so I've kept to that. Now, just let me remind you, next Thursday, a week from tomorrow, is Thanksgiving. Yay. I don't know about your family, but my family, the turkey isn't the only thing that gets stuffed. We all do. Ah, all right. We get stuffed. Woo. But anyways, by the way, my family, everybody knows how to cook real well. And quick thing. Does everybody know what the pupik is? That's Yiddish for your back end. And the favorite part of the turkey for me and my brother-in-law, unfortunately passed away almost 2 years ago, about when he was alive, between the two of us, our favorite part of the turkey was the tail, which we called the pupik. Oh, is that good? Ooh. Anyways, back to real life. And that is next Wednesday, a week from today, COD will not have classes. The offices on campus are open, but there will be no classes and no teaching on next Wednesday, the day before Thanksgiving. And therefore, next Wednesday, I will not have a Zoom meeting. Next Wednesday, I will not have my office hours because everything's closed. And I'll remind you next week. So once again, next Tuesday, I will be giving quiz 5. Now, there's another important announcement I have to make. All right, everybody see assignments on your screen. All right, now there's something new. Ooh, Chem 1211, extra credit, fall 2022. And here it is. Let's go through it. Extra credit project, 10. Hold on, I got really 10 points, bonus points. It's due by December 12th of this year. No late projects are accepted. All right, how do I get those 10 points? Well, the extra credit project is to create a list of ionic and covalent molecules. I don't know why this didn't get bold, but it didn't. Molecules found in your ingredient list of products that can be purchased, i.e., that's Latin for that is, things you can use in your daily life. You must find 5 different molecules that contain five ionic bonds and 5 different molecules that contain, this is important, only covalent bonds. Now, you can only use 3 molecules per product, so you got to look at a couple of labels to get your stuff. Now, how do you get your 10 points? Well, to get the points, you must upload a MS Microsoft Word file or PDF file table with the product name, the molecule's name, and if it's ionic or covalent. Now, be sure to put your name on the table in case I get things mixed up. I shouldn't, but it's always good to do that. just like you should put your name on your test. You'll get 1 point for each correct entry with a total of 10 points. And I've had students, how come you only gave me 8 points, Dr. White? Well, you only put down 8 things. You got to put down 10 entries correctly to get 10 points. Now, you cannot use gasoline, water, sodium bicarbonate, carbon dioxide, ethanol, also called ethyl alcohol, sugar, sodium chloride, table salt, oxygen gas, O2, nitrogen gas, or air. Everything else is fair game. Now, what your table should look like is 3 columns. The first column is the product. Second column is the molecule you're picking from that product. And the third type is bond type. And example, and you can't use Coke. Well, you can, but you can't use water, but I'm using an example, and it's covalent. And you can't use sodium chloride, but I'm using it. Campbell's chicken noodle soup has a lot of sodium chloride. That's ionic. Now, note, ingredients must appear on ingredient list of the product. You can't say, well, banana has this molecule in it, which it does, but as far as I know, I have never seen bananas for sale with ingredients list on them. Never. Now, this is an optional project. You don't have to submit it. You don't. Now, please note, this is an individual project, and if you use items from another student's list, then that's cheating, and I will follow what's in my syllabus for people caught cheating, which means you'll get a 0, and also I'll notify the dean of students. You don't want that. And since I have a photographic memory, when I grade these, well, these look familiar. Wait, this student and this student have the same ones. That's cheating. And I actually, unfortunately, have caught students doing that, but don't. It's not that hard. Now, how do you find out if something's covalent or ionic? Well, you can use Google, or you can ask your instructor to find out if a molecule is ionic or covalent, if you don't know. Again, the due date is the 7th of December. Got a couple weeks to do that. Now, if a compound has in its name an alkali metal, an alkaline earth metal, or a metal, it's going to have an ionic bond in it. So if you have sodium acetate or sodium stearate, which are molecules you can use or find in your daily life, as soon as you see the word sodium, it's going to have at least one ionic bond. And for the covalent molecules, they can have no ionic bonds. Now, how hard is it? Well, it's wintertime. One of my favorite products, I don't get any kickbacks. Ah, shucks, I got to find a way to, but I've been using this product for years. And if you look on the label, you'll see ingredients, and one of them says phenol. Hold on. I'm going to do something I haven't done before in this class. Put on glasses. Now I can read it. And you'll see there's phenol. There's also menthol. So I can get 2 covalent molecules. Oh, I just gave away 2 points from here. So you put Carmex, phenol, and then covalent. I don't need these anymore. If you go back and look at the old videos, you'll see I have my regular glasses. And with those glasses, when my eyes were like that, I didn't need reading glasses. But since I had my cataract surgeries, which has been almost a year now since I had it, I don't need glasses except for reading tiny stuff like this. All right, so if you are going to do the project, listen carefully. I would highly recommend you email me your project before you submit it to Blackboard. And don't do it the day before it's due. Give me a couple of days, like a week before, and I'll check it. If something's wrong, I'll let you know, and I'll help you fix it. So there's no reason every student who wants to can't get 10 bonus points. All right, wow, that's a lot of stuff we've covered today already. Any questions? All right, now it's new chapter time. New stuff. And here, if you have the book, which you don't really need, but if you did, I did chapter 15 before I did chapter 14, which the author should have done too. But now let's get to work. Let me just close one thing here. All right, everybody see chapter 14 on your screens. Thank you, Gianna W. All right, and Jasmine too. All right, chapter 14 deals with acids and bases. This chapter is probably the most useful, important thing I will teach you this semester. It's useful for your daily life and probably other classes too, and other things. All right, so acids and bases. What's an acid? What's a base? Well, it turns out in chemistry, this was a very hard question to answer. Really, it was. So, one chemist, Arrhenius, came up with a theory. Now, listen carefully. For the Arrhenius theory, click, the switch is off. This will not be on a test or a final, and I'll explain why. But the Arrhenius theory dealt with an acid. Arrhenius acid is a hydrogen-containing compound that in water produces hydrogen ions. And an Arrhenius base is a hydroxide, which is OH minus, containing compound that in water produces hydroxide ions. So this is what an Arrhenius acid and base is. And says, see examples on board. I've got room to write it right here. So this is an acid. It's called hydrochloric acid. And in water, this dissociates to give the hydrogen ion plus the chloride ion. And because in water it dissociates to give H plus, the hydrogen ion, it's called an acid. Now, an Arrhenius base example would be sodium hydroxide. And remember, switches click off. And in water, this dissociates to sodium cations plus hydroxide, OH minus, anions. And because of that, it's called a base. Now, Arrhenius base and Arrhenius acid. You know something? I haven't done this ever before. So back in the late 1800s, that's when Arrhenius was active and came up with this theory. I just wanted to check that. It's interesting to know. So this is an Arrhenius base. This is Arrhenius acid. Now, if you notice, there's something common that causes a serious problem. And that's an Arrhenius base is defined by something happening in water. And Arrhenius acid is something defined by what happens in water. Guess what? There are a lot of reactions that occur that are not in water. And how do you do that? What do you do? Well, we'll find out in a little while. But first, there's some key acids under the Arrhenius theory, and also another theory I'll talk about this morning. Click, switches on. Better yet, oh, it's subtle Wednesday. Hint, know this. All right. And what I mean by that is you should know the name and structure of these key acids. Hydrochloric acid has the structure HCl. And why is this a key acid? Well, one of the miracles of life in my mind is this is your stomach acid. And we have cells, I do and you do, in your stomach that synthesize, that's the fancy word for make, hydrochloric acid. And that helps break down your food. And if you're taking my Chem 1212 here at COD, which I'm not teaching this semester, next semester, or my Chem 170 at Elgin Community College, which next semester and this semester I am teaching, I would teach the organic chemistry of how HCl and water breaks down fats and oils, carbohydrates, and proteins to keep you alive. So hydrochloric acid, HCl, you should know the structure. So if I ask, draw the structure, 3 points of hydrochloric acid, you should be able to do that. Next acid is sulfuric acid. And sulfuric acid, the last time I checked, was the most widely manufactured chemical, period, in the United States, if not the world. And sulfuric acid is used for many things in the chemical industry, but let's go out. Everybody see the car battery on your screen right now? Thank you, Gianna J. All right, you look over at this one or the one that's in color, you'll see there are plates and there's a volume here. And inside the plate, there's electrolyte, and that's sulfuric acid solution. So in your car batteries, there's sulfuric acid, and that helps make the battery make electricity, which starts your car. So sulfuric acid is a very important acid, H2SO4. The next one is nitric acid, HNO3. And nitric acid is used with sulfuric acid in the chemical industry to make a lot of things one of them is explosives. How many of you have ever heard of nitroglycerin? Or how many of you have ever heard of TNT? Wow, you guys have lived a sheltered life. Well, nitroglycerin and TNT are both high, very powerful explosives, and you make those with nitric and sulfuric acid, but I'm not going to tell you how. But nitric acid is also used to make other molecules that are used in our daily life that are not explosives. Now, the last one is acetic acid, and is acetic acid, and I'm not going to ask you to learn the structure, but I'll show it to you now. And you used it in the lab I talked about yesterday. Also, when you look at yesterday's lab, I posted in the lab assignment the link to the video and where in the video I did yesterday, helping you understand what to do for that lab. And also the warning, remember, silver nitrate you'll be using for LeChateliers principal lab, yesterday's lab I talked about. Wear your gloves because it will turn your skin black. All right, this is a structure for acetic acid. Now, why do I have this down here? Well, let's find out. If you take about 4% acetic acid and about 96% water, and you mix them together, you'll get a homogeneous solution. And I think I'm going to sneeze. Hold on. Doesn't want to come out. I stifled the sneeze. But anyways, if you mix them together, you get a homogeneous solution, and we have a name for that solution. Vinegar. Vinegar is a mixture of acetic acid and water, any vinegar. Now, certain vinegars have minor other things that make them taste different, but they're all essentially acetic acid and water. And one of the bigger brands is Heinz. Now, does everybody see the rice vinegar on your screen? Whoops, maybe I didn't. Thank you, Gianna. All right. Oh, I forgot about the new thing. But anyways, this Marucan seasoned gourmet all natural rice vinegar is probably my favorite vinegar if I'm not going to use this plain white vinegar, not named after me. And now it's everywhere. You can even buy it at Jewel. Years ago, the only place you could go was a good Japanese food store. And there's a big one by my house. And not that I get any kickbacks from them, but Mitsuwa Marketplace is in Arlington Heights. And if you've never been there, you should. It's a trip. Walking through there with the different stores plus the supermarket makes you feel like you're in Japan. It is an amazing place to visit. And the first time I went in there, when a friend took me there, had heard about, let's go. We walked around and we both looked at each other and said, wow, are we in Japan or what? And they've got some great stuff. Well, that's where I used to be able to buy Marucan vinegar, but now you can buy it a lot of places, even Jewel. So next time you pick up a bottle of vinegar, you know it has acetic acid, which is an acid. It gives up a proton. Now, there's some key bases you should know. Subtle Wednesday, hint, know this. Now, let's look at some of the key bases. The first one is sodium hydroxide, NaOH. Now, the old name, like back in the 15, 16, 1700s, was lye. And how many of you ever heard of lye soap? Boy, I've got to really open your horizons, and I will. Lye soap, the settlers, and for many generations, if you take animal fat and you boil it up in water with lye, sodium hydroxide, you will make soap. And that's how we make soap. And your bar soap is made from sodium hydroxide and animal fat. By the time you get it, it's been purified. I've actually worked in this industry. That's sodium hydroxide. It's a base. All these on the list are bases. Another key base is potassium hydroxide. And the old name was potash because they first discovered it under the pots where you boiled water in the old days, the wood. When wood burns in the ashes, there's a lot of potassium hydroxide, and that has the structure KOH. Now, another important base is ammonia, NH3. And ammonia is used to make things like our fertilizer that helps feed all of us. So this is an important molecule, ammonia. And unfortunately, ammonia is also used to make explosives. And finally, the last one, sodium bicarbonate, NaHCO3. And you find that in baking powder. And later this chapter, not today, I don't think I'll get to it, I'll talk about the first chemical reaction I ever did with my hands when I was about 6 years old. My father showed me how to do it, and it's a really neat story. I'll also tell you later on this chapter, using baking powder, sodium bicarbonate, how to make the best spaghetti sauce, which my father taught me how to do it. All right, so you should know, if I ask on test, what's the structure of sodium hydroxide, NaOH? What's the structure of potassium hydroxide, KOH? What's the structure of ammonia, NH3? What's the structure of sodium bicarbonate, NaHCO3? I think I just said test. This is quiz 6. 1, 2, 3, 4, 5, 6. 6. This will be on quiz 6. All right, now, the problem with the Arrhenius theory is what happens if you work with acids and bases or molecules in non-aqueous solutions where water isn't present? Well, how do you identify an acid or base? and the Arrhenius theory couldn't. Now, how do you replace that? Well, that was a hard problem because everything that was an acid base in the Arrhenius theory, this new theory also had to be an acid and base in water, but also work with things that were not in water. And two chemists independently, Brønsted and Lowry, came up with their acid-base theory. And you know something? Back to the internet. And this theory isn't that old. It's less than 100 years old, which in the history of mankind isn't that long ago. And two chemists, Brønsted and Lowry, independently came up with a theory. And because they did it at the same time, it's been given both their names. And of all the things I'm going to teach you this semester, this is one of the most important things I can teach you in chemistry. Ooh, what's that then? So what is the Brønsted-Lowry acid-base theory? And I better get subtle. Everybody get the message? And know this. All right, what's the Brønsted-Lowry acid? That's any substance that can donate a proton. Proton is defined as H plus to another substance. And notice I even put it in red here. You should know Brønsted-Lowry acid, proton donor. You should know Brønsted-Lowry acid, proton donor. And a proton is H plus. If I'm on Brønsted-Lowry acid, I have my proton and I say, here, take it, And I'm an acid, Brønsted-Lowry acid. So Brønsted-Lowry acid is a proton donor. And you should know this. All right, what's a Brønsted-Lowry base? And it's time to get subtle again. And know this, and a Brønsted-Lowry base is any substance that can accept the proton H plus from other substances, chemicals. So if I'm a Brønsted-Lowry base, I'm a proton acceptor. And I'll go around and say, give me your proton. I'm a Brønsted-Lowry base. So let's go through this again. A Brønsted-Lowry acid is any substance that's a proton donor, proton being H plus. So Brønsted-Lowry acid, proton donor, H plus. Brønsted-Lowry base is a proton acceptor, means give me your protons, I want them, because I'm a Brønsted-Lowry base. And a proton again is H plus. And you should know this. Now, the switch is still on full. There's something called the hydronium ion. In water, H plus, a proton, reacts with water to form the hydronium ion, H3O plus. And this is so important a molecule that it's given its own name as a polyatomic ion, hydronium ion. And this is an actual molecule, and there's a covalent bond between each hydrogen and the oxygen. Now, earlier I said Brønsted-Lowry acid-base theory, you don't need water. And if you have hydrochloric acid as a gas and ammonia as a gas, and in the air you let the vapor of each compound come together, you have an acid-base reaction and you make ammonium chloride. And this is a white solid. And these are clear gases, no colorless, totally colorless gases. And because this is giving the proton here, notice it has a hydrogen here, none there. This has 3, now has 4 with a plus charge. So the ammonia accepted a proton, that's a base. The hydrochloric acid is an acid because it donated a proton. And that's the key thing about the Brønsted-Lowry acid-base theory. If you do this in water, you can identify what's an acid, what's in base, the same as the Arrhenius. However, the Brønsted-Lowry theory allows you to also identify acids and bases in non-aqueous solutions or situations. Just to show you something cool. Everybody see YouTube? Let me check. Oh, no, I'm not YouTube. All right, do you see a gray screen at the top? It says ammonium chloride. Thank you, Gianna. All Giannas and Jasmine, too. All right, let's play this.
Hello guys, this is another episode of the Backyard Scientist, and today I'm going to show you the reaction between hydrochloric acid and ammonia. And there's a reaction in the gas phase and the liquid phase. And you can see that even though that I have the hydrochloric acid with a cap on it, it's still reacting with ambient ammonia in the air. So what happens when I take this off is the hydrochloric acid vapors immediately react with the ammonia in the air, and it produces a very strong smoking effect.
And what's happening is the ammonia is reacting with the hydrochloric acid gas in the air.
I was enjoyed. I think it's a pretty cool experiment. And
I
then,
agree. And that's the reason why you have the Arrhenius theory drop, because in the air there's no water, but they still reacted. And it was an acid-base reaction. And you should know, once again, let's go through it again, what's a Brønsted-Lowry acid? If I ask on a test, what's a Brønsted-Lowry acid? Hint, know this, it's a proton donor. Brønsted-Lowry acid, proton donor. And what's a Brønsted-Lowry base? It's a proton acceptor. A base, Brønsted-Lowry base, is a proton acceptor. Now, henceforth, I won't use Brønsted-Lowry. I'll just say acid and base. But by saying acid and base, I'll assume you know, even though I shouldn't really assume in life, but I will, that you know I'm talking about Brønsted-Lowry, not Arrhenius. Now, there's another definition way of defining acids and bases that's very specialized, called Lewis acids and bases, and we're not going to cover that in this class. But for everyday life in yours or in mine or in the chemical industry, if somebody says this is an acid or this is a base, they're talking about a Brønsted-Lowry acid or base. Remember, Brønsted-Lowry acid, I'm a proton donor, take my proton. And if I'm a Brønsted-Lowry base, give me your proton, give me your proton, I want it because I'm a base. And if I look at the clock, it's time for a break. So let's take a 5-minute break and we'll continue on with this exciting acid and bases chapter. See you in 5. I haven't used this in a while. Time to get started again. Sorry I'm running late. I had to find a book with some examples I wanted to show you in a little while. All right, let's continue acids and bases. And remember, a Brønsted-Lowry acid is a proton donor, and a proton is H plus. A Brønsted-Lowry base is a proton acceptor, and again, a proton is H plus. Now, in water, it can react with hydronium with H plus, a proton, to form the hydronium ion H3O plus. Now, when we talk about acids and bases, there's an important concept called acid-base pairs. And in most acids, not all, but most, you don't have 100% proton transfer. And this is an equilibrium. Oh, you learned about equilibrium. And in chemistry, we use HA, oops, wrong color, as a general acid. B, guess what, is a base. Now, this transfers a proton, H plus, over that. Therefore, if you lose H plus, the acid becomes A minus, and the base, because it accepts a proton, I like those fancy special effects, accepts a proton, becomes HB plus. Now, this general acid-base reaction, which is an equilibrium, because of double-headed arrows, we have a concept called conjugate acid-base pair. And conjugate acid-base pair are two species that differ by only a proton. Remember, a proton is H plus. So we call this a conjugate acid-base pair. And the conjugate base of an acid is the species that remains when the acid loses a proton. And the conjugate acid of a base is the species that is formed when the base accepts a proton. So conjugate base of an acid is what's left over after an acid gives up its proton. And a conjugate acid of a base is what's left, or what's created actually, when a base accepts a proton. Highlight those special effects. Seaboard, for example. Uh-oh, I better get to work. It says one right, an A right there. Anyways, 1 point each. Identify the following as acid-base, conjugate acid, conjugate base. Now, in general, let's do this first. Now, a conjugate are two species that differ by H plus. And if you notice, These two that I just marked in blue are conjugates. The only difference is H plus. And in purple, or this is rainbow, I guess, B and HB plus are also conjugates. And they differ by H plus. Now, for this problem, you have to identify each of the four as acid base or conjugate acid or base. Well, how do you do that? Let's look at X. When X goes to its conjugate, W, does it gain a proton or lose a proton? Now, for students, just follow. Does it gain an H or lose an H? And the answer is it lost an H. And therefore, it's an acid. Now, let's look at Y. When Y goes to its conjugate Z, does it lose a proton? Think of this H, or gain a proton? Think of this H. It goes from B to HB plus. So it accepted or gained a proton. And a proton acceptor is a base. Now, I should mention on the left side, by convention, are the acids and bases. And the right side are your conjugates, acids and bases. So immediately I can write this. Now let's look at W. When it goes to its conjugate X, it's going in this direction now, where before we were going from right to left. For this right here, the direction of the equilibrium was that way to determine whether or not we had an acid. Now, if we look at W, when it goes from W to X, is that an acid or is W a base? How do you remember that? Remember, hold on one second. Yep, there's one N in donor. I forgot, and I don't want to make a spelling mistake. Now, acid is a proton donor, base is a proton acceptor. And you can have a conjugate acid or base. So if we look at W, it accepts a proton. Anything that accepts a proton is a base. So it's on the right side, and we call that a conjugate base. And we're left with Z going to Y. And again, we're going this direction now. And when Z goes to Y, does it donate a proton or accept it? Count the H's. Z has an H, Y has none. And that makes it a proton donor, gave up an H plus, and that's an acid. So what you have to do is find the conjugates. Conjugate are species that differ by one proton, but for this class, just count the H's. And a base, those are the conjugates. Do what I just did here, and then identify using the Brønsted-Lowry theory of acid space. Is it a proton donor, acid, proton acceptor, base? And remember that the left side are just the acid and base, and the right side of the equilibrium are the conjugate acid and base. All right, let's do the same thing. I had to check in the book an example and label X, Y, W, and Z as acid, base, conjugate acid, or conjugate base. The same problem, identify the following as acid, base, conjugate base. 1 point each, which means a total of 4 points. So how do we do that? Well, the first thing is identify the conjugates. Why don't you try that first? What letter on the right is the conjugate on the letter of the left? What letter on the left is the conjugate on the right? Why don't you try that? They only differ by one proton, H plus, but for students, just follow the hydrogen H. If something loses an H, it's an acid, or the difference between two, if they're one proton or one H difference. Why don't you try just following, identifying the conjugates as a line? Like what I did here with the blue line and the rainbow line. And when you're done, or if you want me to start doing it, give me a thumbs up. And this is tricky the first time you're doing it or second time you're doing it. Give you another minute and then I'll do it. I'm watching the clock up there. I just realized I don't have a clock in my house that goes tick-tock. They're all electronic. All right, my turn. Now, the first thing to do is identify the conjugates. Now, giveaway is this has phosphorus, this has phosphorus. So they're the same in terms of having those atoms. The only difference, this has 3 hydrogens, this has 2. These are conjugates. Now, I'm trying a new color. I've never used this before. Look at Y. I'm not going to use it again. Hold on. It's sort of okay. Y and Z. What's the difference? Well, a proton. Count the hydrogens. It's easier for students. This has 2. This has 3. And hold on while I do something. I don't even like this color. Let's try green. Yep, it's all right. So here, and sorry about the technical delay, but all right. Anyways, in green here, something. I'm going back to red. Right here, these two differ by a proton. But now we have identified the conjugates, species that differ by a proton. And let's look at X. When X goes to its conjugate, W, does it donate a proton to something or it accepts it? Count the hydrogens, goes from 3 to 2. That means it donated, gave up. What's something that's a proton donor? Come on, hold on. There you go. It's an acid. So X is an acid. By the way, this is called phosphoric acid. And next, let's look at Y, water. And when water goes to its Z, does it accept a proton or donate a proton? Count the hydrogens, one from 2, no charge, to 3 with a charge. It accepted a proton. And a proton acceptor is a base. Now we'll go to the other side because we were looking at what happens when things X and Y shift to the right. Now, we'll look at the other direction. when W and Z react. And if we look at both of these, remember on the right side, they're both conjugates. So if we look at W, when it goes to its conjugate X, that's why we took time to put the blue line there, it goes from 2 hydrogens with a negative charge to 3 hydrogens, no charge. It picked up or accepted a proton. What's a proton acceptor? It's a base. So W is the conjugate base of the acid X, which makes sense, but the way I'm teaching you is the easier way to do it. Now we just have Z to go, and Z, the hydronium ion, H3O plus, goes to water. Why? Does it gain or donate, lose a proton? Think of hydrogens, went from 3 to 2. It lost one. It gave it up. And what's something that loses a proton or donates a proton? It's an acid. And being on the right side, it's a conjugate acid. And that's how you do it. Oh, let's do another one. I'll help you. This I won't do on a test, but remember, everything on the right side of the equilibrium is a conjugate. And you have to find, if you are doing this, what's the conjugate acid, what's conjugate base, what's the acid, what's the base, 1 point each. Now, what I'd like you to do on your own, and then I'll help you out, next part is, we'll do this stepwise. Look and take a pencil or in your mind, which are the conjugate pairs? One chemical on the right or the left and one on the right. And just like I said, conjugates differ by 1 proton, but just count the hydrogens to make sure the rest of the atoms are the same. Your turn now. Remember, this is material for quiz 6. Next Tuesday, I'll be giving quiz 5 online. And when you've identified just what 2 species are conjugates, give me a thumbs up. Or if you want me to go ahead and do it for you, give me a thumbs up. Or you can do a thumbs down or any other emoji, which I'm still like to call symboli, but they never will. Thank you, Jasmine. Thank you, Gianna. W. least nobody put up the one that they have with the crying eyes on the face. Yeah. And I'll give you one more minute. Thank you, Gianna J. All right, everybody's done, so I can get to work. Now, here's a little secret, not really, but notice X has a carbon and Z has a carbon, but on this side, Y doesn't. So these have to be conjugates. But let's find out if I'm correct. Let's use blue, and these are conjugates. Notice this is H2CO3. This is HCO3. So you've lost a proton. Just count the hydrogen. Went from 2 to 1. So those are conjugates. Now let's look at water, W. And if we look at Y, the only difference between W and Y, water and hydronium ion, is H plus. Discount the hydrogens, 2 to 3. I'm looking over here. Why am I looking at myself? Stop. But anyways, so we know the conjugates. Now, one interesting thing that students make a mistake, they assume, though, from the examples I did previously, acid always first, base second. No, they can be reversed. And let's look at this case, because I did that. We look at W, water. When it goes to Y, the hydronium ion, has it donated a proton or accepted a proton? And it goes from 2 to 3. So it's accepted a proton. And what's a proton acceptor? A base. And if we look at X now, X goes to its, which is called carbonic acid, goes to its conjugate. I had a brain freeze for a second. Z, which is carbonic, the carbonate anion, does it gain or lose a proton? Count the hydrogens, 2 to 1. Is that a gain or loss? It's a loss. So it's donated, lost a proton. What's something that donates a proton? That's an acid. All right, now we were going this direction. Now we're going to do the reverse. Go this direction. And let's look at Y. When Y goes to its conjugate W, does it gain or lose a proton? Count the hydrogens. It's easier for students. Goes from 3 to 2. And it's lost or donated a proton. What's a proton donor? An acid. And because it's on the right side of the equilibrium arrows, they're conjugates. So Y is a conjugate acid. That just leaves Z. Again, we're looking at when Z goes to its conjugate, in this case X, does it gain or lose a proton? Count the hydrogens. Goes from 1 to 2. 1 to 2. And that means it gains a proton. And what's something that gains or accepts a proton? I like those special effects. It's a base, and because it's on the right side, it's a conjugate base. And it turns out this is very useful in chemistry, knowing what's an acid, base, what's its conjugate. and we've done our examples, so we can move on. Now, in life, just like all people are not equal strength, some people are stronger than others. Guess what? In life, all acids are not the same. Some are stronger. I like the special effects I'm using today. Stronger than others. Dr. White works out with weight still. I pump iron, even at my age, which is a good thing. All right. Thank you. But anyways, not to bring religion into the class, let's look at strengths of acids and bases. Now, an acid that's strong, we have this equilibrium. And this is a general way of showing an acid giving up a proton. This equilibrium, when it's a strong acid, it's almost 100% to the right, which means, you learned last chapter, the K equilibrium is much, 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 much greater than 1, a lot. And C equilibrium on the board, well, I just did that. Now, I'm not going to ask on a test examples, but all the halogen acids, and for this class, I only really taught you one, which would be hydrochloric acid, nitric acid, and sulfuric acid, are strong acids, and they give up their proton like that. They're the strong kind of acids that say, I've got a proton, take it. You don't have a choice. And they're quite strong, and they're also dangerous. Sulfuric acid is in battery acid, and something I still remember, was my mother upset. Back when I was in high school, car batteries had little caps that you could open up and refill the battery acid in. And if you were changing a battery, taking a new one out and put old one out, putting a new one in, you had to watch out you didn't spill any of that on yourself, because it could burn your skin, react, and cause serious damage, or it could burn holes in your clothes. Well, I was wearing a somewhat new winter jacket, helping my father with his car battery, and I didn't realize it, but I spilled some sulfuric acid, a strong acid, on my coat. And within about 5 minutes, there were holes in my coat. Oh, is my mother mad at my father and I? Why didn't you have him wear some sort of apron or something to protect him? And, oh, is she mad? And rightfully so. We should have known better. Now I know better. So hydrochloric acid, and you don't have to know this, just understand, what does it mean? Strong acid. That means it gives up almost all its protons, and you don't want it ever on your skin or anything else. But when you dilute it, like in your stomach, HCl is in your stomach, that helps break down your food. Now, you can have weak acids, and weak acids, again, same type of basic equilibrium. Only just a little goes this way, about 5%. An example of a weak acid is acetic acid, which is found in vinegar. And even though it's a weak acid, it's still, in the vinegar you buy is only 5%, 4%, excuse me, which means it's a dilute solution of acetic acid. But it's safe, dilute solution of acetic acid is safe for you to consume, which, if you know how to make an oil vinaigrette dressing, you use vinegar, vegetable oil, and some seasonings, and you mix it together. I found if you drizzle in the oil into the vinegar in a food processor, you can make a really good. If you use that Marukan Japanese rice vinegar with seasoning like garlic and salt and pepper and vegetable oil, whoa, you make some of the best oil vinaigrette dressing I've ever had. Now, the same thing is true about bases. If we have a base B and react it with an acid H plus, it forms this salt. And for strong bases, the reaction goes almost 100% that way. They just say, give me your proton. And strong bases, the common ones are, and I'm not going to ask on a test, but I think you should know this, are sodium hydroxide and potassium hydroxide. So these are strong bases. You don't want to ever get this on your skin. And these are strong bases. Do I have time? I do. Time to learn something important from Dr. White. That'll help you in your daily life. All right, come on. Thank you. Everybody see on your screen, Instant Power Hair and Grease Remover Drain Opener. Thank you, Gianna J. All right. Interesting Dr. White story. When I moved into this house a long time ago, I'd been living here about 3 or 4 weeks. And guess what happened? My kitchen drain of my kitchen sink was totally stopped up. Oh no, I just bought this house. Well, anyways, I figured, all right, I bought the house. I called the Roto-Rooter local person. He came out, put his Roto-Rooter thing down there, cleaned it out. It was running again, and said, here's a 6-month guarantee. If it clogs up again, I'll come back free. I said, thank you. Well, in about a week, guess what? It clogged up again. So I called him and he came out, apologized. I don't know, did the Roto-Rooter thing. And I thanked him. And within about a week or so later, it clogged up again. Now, at this point, I was working at a chemical company. I'm salaried, 6-figure salary. That was nice. And yep, 6-figure. And I had to stay home and wait for this guy because I live alone now. And back then too. And I had things to do. I should have been at work. And it was not fun to have to wait for this guy to show up and be home and get to work real late. And so he came out and had a bottle of stuff, and I'm an organic chemist who knows surfactants, which I teach in my 1212 class here, and also Chem 170 at Elgin Community College. I looked at the label and I saw, hey, this is going to work. Well, he Roto-Rooted again, put that down and apologized, and it was still under warranty, so I didn't get charged, but I'm wasting time. Within about 2 weeks, it clogged up again. And I said, you know something? I've wasted enough time with this guy. Forget about the money. I'm just wasting a lot of my time. That's more important. So I went to Home Depot. I'm looking at this whole long wall of drain cleaners. And because I know acids and bases, and I know acids or bases will clean out the clog, which is grease or fat and oil in my drain from the previous owner. That was what was clogging it up. Well, I picked up a bottle here and here and there, hydrochloric acid, because I know an acid. And a real nice gentleman comes over who works there. And the Home Depot I go to is in Barrington, on Barrington Road. Is that Barrington or is that still Schaumburg? No, it's Schaumburg, I think, but in Barrington Road. And can I help you? And I said, yes. All these drain cleaners, and once in a while I think well and do something smart. And that day I did. I said, which one of these do the plumbers use? And like that, he said, that one. So I picked it up, and which one was it? This, the hair and grease drain opener. And interestingly enough, this is the only one of all the different products that comes in a thick plastic Ziploc bag, and on the side of the bag, in red letters, it says, use eye protection. And I picked up and looked at the label, and the label says contains, I don't see the label here, but potassium hydroxide and sodium hydroxide. And the others had hydrochloric acid, HCl. So I look at that and say, oh, this one contains a base and those are acids. And the funny thing happened, this gentleman at Home Depot, who was very nice, helping me out, said, no, that's the acid too. I said, no, I have a PhD in synthetic organic chemistry. I'm a chemist. That's the base. He said, no, that's an acid. And I'm thinking, why am I arguing acid and base theory, which I know I'm right, with someone who just helped me out? So immediately I said, thank you. And I appreciated your help. Thank you very much. I bought the bottle and I went home. I followed the instructions. The only thing I did different, they say let it sit in there for 15 minutes. I gave it a half hour. I also used double what they recommended. And instead of flushing from that sink, I went to my utility room sink and filled the bucket with very hot water. And after it cleared out, I poured that down, a couple more, and then I turned on the cold water. And why? Because you learn that when you increase the reaction temperature, hot water, by 10 degrees, the reaction rate doubles, which is why I did that. And it cleaned it out. And for about 10 years, 15 years, nothing happened. And it got clogged up again, which is pretty good because I don't pour any grease or fat down. Like if you make bacon or other things that have fat, I separate that, put it in a Ziploc double baggie in my garbage can. I don't want it in my pipes in my sink. And about 15 years later, I've been here since 98, it clogged up again. And I keep a big bottle in the house. I poured some down, waited, followed directions. By the way, I do wear safety goggles and wear a long sleeve top to protect my skin and gloves. And it worked like a charm. And I've had many students use it and it works like a charm. Now, it happened to my sister before I had to use it, and also other students in the bathroom. If your sink or tub drain, shower drain clogs, that's because of hair, mostly. And acid and base will break down hair, so it cleans the clog. I teach that chemistry in my organic chemistry, but I won't go through it here, the actual chemical reaction. But you follow the instructions, it works like a charm. And about a year and a half ago, my main bathroom sink over that way, through that door and around the hall, anyways, clogged up. And after 20 years and plus, it finally had some gunk in there and here and whatever else. And I did the same thing, poured some of the drain cleaner, followed the instructions, wore safety goggles, boom. It's like brand new again. That was a year and a half ago. So I would highly recommend, and many students have used this, and that is this drain cleaner. It's the only one in a black bottle. It's the only one that's in a Ziploc plastic bag, and you can get it at Home Depot. I think some of the other home improvement stores probably have it, but that's where I've always bought it. And I also learned an important life lesson. Don't argue chemistry with someone who works at Home Depot or any other store. Just thank you, you helped me, and true story. Well, I only tell true stories. Now, a weak base you should know is sodium bicarbonate. And that's a weak base. And a weak base says, could you please give me, maybe give me your proton? And here again, base plus acid, it's an equilibrium. And the equilibrium is mostly this way. Less than 5% goes this way, which is why I wrote a little tiny arrow instead of a big one. Now, the conjugate bases of strong acids are weak bases, and this I'll never ask on a test, but you should know for the rest of your life that sodium bicarbonate is a weak base. And if I look at the clock, this will be a good time to stop. Let me remind you, the lab that was due yesterday, I've extended the time because I put up calculations, how to do the calculations for the airbag. It's due next Tuesday. The lab you did yesterday with the Chandler's principle, I had to think for a second. That's due next Tuesday. And next Tuesday, we will have quiz number 5, which I posted the announcement for. Well, next Monday, I will go through chapter 15, problem set. I will also do my world famous review for quiz 5. And with that, have a nice rest of the day. If you need help, I'll have my office hour tonight. If not, have a nice rest of the week. And I'll thank you, Jasmine. And I'll try and have a good one. You do too. And I'll see you next Monday. Gang gesund. Goodbye. I stole that from Granny and the Beverly Hillbillies.